Now we're going to determine the domain and range of two radical functions without knowing anything about the graph. If we had the graphs, it would be easier, but I want you to know how to do this when given just a function with no accompanying picture. And what we're going to do is something similar to what we did with the pictures, which is talk in terms of the least and the greatest allowed values of x and y. And I think I'm going to start with range actually first. It's going to take a little less space to talk about this. So let's say for this first equation, or the first function, not y mix, my y minimum value. So what is the smallest y can be? Well, it's going to be 4 times the square root of 0 minus 3. See, when I have that radicand, this part under the parentheses, and I think about the kinds of values that could be, they could be big, they could be small, but they can't be negative. So the smallest it can be is 0. So what is 4 times the square root of 0 minus 3? Well, that's just negative 3. And likewise, what's the maximum it can be? Well, think of a really big number. Usually people come up with a big one, like a billion or infinity. So what's 4 times the square root of infinity minus 3? Well, the square root of infinity is infinity, right? It's just too big to even talk about. 4 times that is still extremely big. And subtract 3, it doesn't matter, it's just infinity, right? It's a huge number. So that means the range is going to go from negative 3 inclusive, meaning square brackets, all the way up to infinity. And we can do this for the next one. It's not that much harder. For this one, I'd say, well, negative 2 times the square root of 0 minus 5 is what? Well, negative 5 from the looks of it. And my y max equals negative 2 times the square root of, pick a big number, infinity, minus 5. Now this one's got a little bit of a twist to it. The square root of infinity is infinity, times negative 2 is going to give us negative infinity minus 5. So this one actually equals negative infinity. And you might be thinking, well, hold up, I thought that was the maximum. That's less than negative 5, not greater. Well, I'm using the terms min and max kind of loosely. The point is, the extremes, that would be a better word to use. The extremes are negative infinity and negative 5. So let's put those in here. Negative infinity can't be touched, so that gets the parentheses. Negative 5 is inclusive. We do touch that point, so that's a square bracket. So that's how you find the range. The domain it's a little bit different method. For the domain, you really must talk about domain restrictions. And we'll talk about that first one first, number 1 up here. So with number 1, the domain restriction is that negative 2x minus 3 must be greater than or equal to 0. Think about why that is. Maybe pause the video, convince yourself this is true. The reason is you can't have this less than 0 or you're going to be square rooting a negative. That means you get imaginary numbers. And we're trying to avoid imaginaries. We're only looking for real numbers. So move things around a little bit. I'm going to say that means negative 2x is greater than or equal to 3. I added 3 to both sides. I don't like having negative x's, so I'm just going to add that to the other side. See, sometimes this takes a little bit of work until you're happy with how it looks. So that means 0 is greater than or equal to 2x plus 3. That means negative 3 is greater than 2x. Likewise, you can divide. Negative 3 over 2 is greater than x. You could have done this faster if you divided by a negative 2 early on. As long as you remember that flips the sign of this inequality from greater than to less than. I don't like remembering that personally, so I just add to both sides until I get a positive x, and then I'm happy. Now, x less than negative 3 halves. What does that mean? Think about in domain. That means x could be negative 10, x could be negative 20, negative 30. It could be any negative number as long as it's less than or equal to negative 3 halves. So the way you write that is like this. All the negatives up to and including negative 3 halves. And that's going to be the domain. Let's try number 2. This one's a little more complicated. This is a lot more complicated. Negative 2, I'm just going to write this again over here. X squared minus 5x plus 4 minus 5. Okay, what's the restriction? Remember, it's the domain restriction that's important. X squared minus 5x plus 4 must be either a positive number or 0. If it's negative, you're square rooting a negative, that's bad. So how do we figure out where x squared minus 5x plus 4 is greater than or equal to 0? Well, if you remember from class, we just finished talking about polynomial inequalities. So this is perfect timing. If I factor this, I get x minus 4 times x minus 1 is greater than or equal to 0. Now you can draw a graph, or you can solve it using a sign chart. I prefer the sign chart myself. I'm going to draw a number line right here, put my x-intercepts on there. I have x-intercepts at 1 and 4. My factors are x minus 1 and x minus 4, which are both positive above 4. X minus 4 is negative below 4. X minus 1 is negative below 1. We multiply out our signs here, and we get the following sign result. Meaning, where is this positive? Remember what I'm looking for. I'm looking for greater than 0 or equal to 0. And that's over here and over here. Equal to 0 at those x-intercepts is just fine. So what I would say is, here's my solution. It's everything less than 1, negative infinity to 1, and it's everything at x equals 4 and above. That's the domain of this problem. If you imagine this a different way, remember that x squared minus 5x plus 4 part? If I had graphed that, let's bring this over into a graph. What does that look like? Well, you have x-intercepts at 4 and 1, maybe right here and right here, and it's going to look like some kind of a parabola. So that's my graph, and I'm saying, where's this thing positive? Well, you can see it's going to be all these values less than the left intercept and greater than the right intercept. And of course, that's not the graph of our square root function. The square root function is going to be complicated looking. That would have a graph that looks, I don't know, something like this. Something weird. We're not getting into those. All that's important for me right now is, what's the domain? In other words, where are the real values of x? This is how you do it. I think the sign table is the better way to go at it. But if you like graphing polynomials, go ahead and graph a polynomial. See where it's positive.